numerate students, numerate graduates are hugely valued, and there was some research not that long ago which suggested that people with Maths A-level earn 10% more throughout their life than similarly qualified people without Maths A-level. Maths was always required for physics, for engineering, for computing. What's changed in the last 20 years or so is more and more what we used to call social sciences, or economics, psychology, geography, etc., have gone from being art subjects to science subjects at universities. They've gone from being BAs to BScs, and in order to be a BSc you need a knowledge of maths, and in many of them you need a knowledge of statistics. In a sense, it's a question you have to ask the other subjects. It's not maths forcing themselves on other subjects, it's other subjects realising the value of maths. It's hugely valued. It comes up everywhere. It's maths itself, if you like, is a universal language, and people work with computers and things like that, which are essentially sort of mathematical sort of devices. And I think it's becoming more and more pronounced. What's also changing is that further maths, which is a separate A-level from maths, which used to be required at a very small number of universities for essentially maths courses. Further maths is now required for physics, for engineering, for some economics courses, and so the range of subjects that want further maths, want double maths A-level, is getting wider and wider and wider. And it may only be sort of 10 or 15 or 20% of the universities, but it's the 10, 15, 20% of top universities. It's the Russell Group universities, it's the one in the sort of top 10 of every table, and so forth, that want it. And so, further maths is, at Duff Miller, maths is the biggest subject, but further maths is about the 8th or 9th biggest subject, and it's getting bigger and bigger, and more people are aiming to do it. What we do, which is unusual among schools and colleges, is where the students have a choice in what are called the applications units, we give them a totally free choice. A lot of the units, the core units, further pure units, are compulsory, but things like mechanics, statistics, decision maths aren't, and many other institutions say, well, everyone in year 12 must do statistics, or everyone in year 13 must do mechanics, and that will suit some students, but equally it won't suit other students. If you have a student who's maybe aiming at doing physics or engineering at university, then they're going to want to do all the mechanics units they can. But if you have another student who's aiming maybe at doing economics or psychology at university, then there's a very good chance they don't like mechanics. If they did mechanics, it would remind them of horrible experiences in physics GCSE, whereas that student would be much, much more at home, much, much more comfortable with statistics or decision maths, plus they know that statistics and decision maths are coming up in their university courses. So the first thing we do is we try to, where possible, give students a maths course to suit their interests and their ambitions. In terms of making the subject interesting, what you need to try to do is you need to try to sort of point out the similarities. So students, they would look at a section, there will be there'll be a question about solving equations, and another question about drawing graphs, and another question about this, and another question about that. But in fact, solving equations and drawing graphs are just two different ways of looking at exactly the same thing, where this particular curve cuts the x-axis, cuts the y-axis, so forth. And so by trying to draw them together, you give them a range of different ways of answering a question. And quite often I say, well, you don't have to draw a graph. Certainly in A-level maths you don't have to draw graphs accurately, but if you think about the shape of the graph, and by the time you do A-level maths there are probably about a dozen graphs you ought to know, if you think about the shape you can see where the answer is, you can see what part of the graph or what feature of the graph leads to the answer. And as I say, one of the problems with a lot of maths courses is they're very, very compartmentalised. There is an algebra bit, there's a geometry bit, there's a trigonometry bit, and you can always borrow ideas from other bits to make questions simpler. And one of the things a very good student can do is to take what looks like a horrific question and to look at it in a different way, and turn it into a relatively easy, relatively straightforward question. You try to show them that different ways that these are, although these have different names, that these are different ways of solving the same sort of problems or looking at the same sorts of mathematical things, and try to encourage them to get a broad view.